Okay, I wanted to take a second to explain this number four on 14.4. It's kind of an interesting question. So what we have here is some drilling data, um, and we're going to try to explain the time it takes to drill an additional 5 feet from any given depth, and for the drilling conditions that you happen to be in, and the conditions are either wet or dry. So we're trying to explain time. We're trying to make a regression model for time using the depth that you start at, excuse me, and the conditions that you're in, wet or dry. Um, so it's kind of interesting in the sense that usually most of the other examples we've had, the explanatory variables are all numeric. So this is one where the variable is qualitative. Okay. Now part A asks us to draw a scatter diagram treating depth as the explanatory variable and time as the response variable, but to use a different plotting symbol for wet and dry. So we're gonna, in other multiple regression settings, we would do a scatter plot for depth versus time, and then conditions versus time. But here, what we're going to do is we're just going to do depth to time, but we're going to label each of the points as kind of either wet or dry. And in the examples they give us here to choose from, they're choosing circles for one and squares for the other. In StatCrunch, we're actually going to do it in terms of colors. So let me show you how to do that. So if you go to graph, scatter, you can choose your X variable to be depth, your Y variable to be time, and you want to group by the conditions. Okay. And the grouping options, color points by group label. I guess we don't have the, we can either separate the two graphs or we can color points by group label. I don't know if there's any way to do it by circles and squares. So you're just going to have to map the circles and the squares in your head. Okay, here's the scatter plot. Always check the axes and see if they're similar. So they start in the same point on the x-axis at 0, and about the same point on the y-axis. They start a little higher here. Looks like at about 5. Oh no, that's the same. They start at 5 here, so that's good. And as you can see, the one that most closely approximates it is the C here. Okay, there doesn't look to be like any discernible pattern there. Okay, so now the next part is we're supposed to find a least squares regression line given the two variables. Now to do regression, we have to have the variables be all quantitative. And so you might be like, well, how am I going to get conditions to be quantitative? So I'm just going to show you real quick. When you have a qualitative variable like that, you can always just, especially if it's just toggling between two things, you can make all the wet ones 0. Or, hold on, yeah, they tell us they want a 0 for wet. I missed one. I think I got them all. Wet, 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 wet. Pays to double check, because if you don't get that right, then your regression equation is going to be off. And I'm going through and doing all the dry ones as a 1. So now instead of using depth and conditions to explain time, we're going to do depth and conditions numeric to explain time. That'll give us our regression line. So stat, regression, multiple linear, and our Y variable is time. And we're going to do depth and conditions numeric. Notice that doesn't even bring up conditions. Okay. And just hit compute. And we're just going to check and see which of these ones it is. So rounded to two places, this is what, 8.40. Yeah, this is the only one that has even the right white intercept. I'm just going to check the rest just to make sure. 0.0036, 0.00367, yep. And then negative 1.394. Okay, so that looks good. This selection B. Okay, now we have to do the hypothesis test for each of the variables. And you notice I didn't do that when I was in the original settings. So we're gonna do the, sorry, here it is. Hypothesis testing. Yep, at 95%. I guess I did. Let's see. Oh yeah, here it is. Sorry, just lost it in the size of my screen. So we have the p-values for each of the different each of the different explanatory variables. So the first one asks, is there a significant linear relation between depth? So we want to see if the p-value and significance is defined here as 0.025. So we want to see if depth has a p-value of less than 0.025, and it doesn't. Okay, so that means that it doesn't have a significant relationship with the time. Okay, so that's why we select no here. Is there a significant relation between the conditions and the time needed to drill another 5 feet? And here, yes, this is below 0.025. So that's why we have this is yes and this is no. Okay, because this p-value is too high. This one's low enough. Okay, now the last thing we have to do, even though we wouldn't use this model because one of the variables really is not explanatory, we're asked to find the confidence intervals for starting at 120 feet. So you can go back into options here. This is where you use, where is it? Oh no, that's right, it's only the single linear, sorry. You gotta do this. You gotta kind of trick stack crunching. So 120 feet in dry conditions, which would be a 1, right? Now what we're going to do here is we're going to get all the predicted, using this model that we've developed, we're going to get all the predicted values here. And that'll tell us what our prediction value is. And we'll also get the confidence intervals for the, we'll get the confidence interval and the prediction interval. Okay. So really we're just making, see, we're not filling this in because we don't have data here necessarily. We do have one data point here, but we want to see what the prediction is for this one. This is an actual data point. We just want the prediction. Okay, so regression, multiple linear. We're explaining time with depth and conditions. Numeric. And yeah. Oh yeah, so this is the important part. So we want to get the predicted value. We want to StatCrunch to save predicted values in a column. We also want it to do the 95% confidence interval. What about lost predicted values? And here's the prediction interval. Okay. So I'm gonna hit compute and you'll notice I'll have new columns on my table. I just kind of get out of this. What I'm really interested here is my new table here. Okay. So looking at that last row that I added, StatCrunch predicted that the time would be 7.44 minutes to drill from 120 feet in dry conditions. And the confidence interval is going to be from, this is the low end of the confidence interval. I always have trouble because it's hard to see the column heading. A little trick I use is if you go to rename column, you can see the whole heading, and it's easy to remember which one's the confidence interval for the mean and which one's the prediction interval. So this is for the mean, the low end, right? The lower end is 6.73. This one's for the higher end of the mean or the confidence interval, 8.15. Sorry, right here, 8.15. And then these two are the ends of the intervals for the prediction interval, 5.496, 9.391. Okay, so that's how you get the different parts of this question. And this video is running a little long, but it's worthwhile to make sure you know what the difference is between this confidence interval and this prediction interval. Okay, you can always ask me. I've explained in a couple other videos, but if you